Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we have an electron in an atom that has orbital angular momentum m equals 0, and we want to know what is the components of the angular magnetic moment and the angular momentum. So for part A, the angular momentum. So we have for part A, because ml equals 0, we have that L orbital is equal to ml h over 2 pi is equal to 0. For part B, want to know the magnetic moment. Again, because ml is equal to 0, the magnetic moment mu orbital is minus ml mu b is 0 again. For part C, we want to know if the atom is in an external magnetic field that has energy U and an orbital angular momentum, magnetic moment. We want to know the energy of the spin associated with the magnetic moment of the spin. So we have for C, again, because ml is equal to 0, energy is equal to minus mu orbital b external, and mu orbital is 0, so this is 0. For part D, we want the information of the spin, and now the angular momentum doesn't play a role. So we have U is equal to plus or minus mu b b, and we can plug values here. So this is 9.27 times 10 to the minus 24 times 35 millitesla. This is joules for Tesla. And this is plus or minus 3.2 times 10 to the minus 25. Let me write this down here. Times 10 to the minus 25 joules. Now for part E, F, G, and H, we want to know if the electron has angular orbital angular momentum equals minus 3. What is the angular moment? And the magnetic moment, the energy of the orbital, and energy of the spin. So we have for E, now we have ml equals minus 3. So L orbital is mlh divided by 2 pi. This is minus 3 times 6.63 times 10 to the minus 27 divided by 2 pi. And we have minus 3.2 times 10 to the minus 34 joule seconds. For part F, we want to know the magnetic moment. So we have the orbital. This is minus ml ub, and this is minus 3 times 9.27 times 10 to the minus 24. And then we have 2.8 times 10 to the minus 23 joules Tesla. For part G, we want to know the potential energy associated with the orbital angular momentum. So we have G, U is equal to minus mu orbital B external, and this is minus 2.78 times 10 to the minus 23 times 35 times 10 to the minus 3, and this gives us a potential energy of 9.7 times 10 to the minus 25 joules. And finally, for H, want to know the potential energy associated with the spin. And because it is independent of ml, so US does not depend on ml, it stays the same. So US is plus or minus 3.2 times 10 to the minus 25 joules. This is the result that we got before.